This video is on factoring quadratics. I've already done a video on factoring quadratics when the a value is equal to 1, and you should probably watch that one first. It'll make this video a little easier. It's not necessary, but it would make it easier. So let's jump in and take a look at factoring 4x squared plus 21x minus 18. So our first step is to go ahead and set up our x box, or sometimes we call it a diamond box. The second step is to put ax squared and c values in the box. So our 4x squared goes in the top left, and our negative 18 goes on the bottom right. Next step, we're going to multiply a times c for the top of the x and place b on the bottom. So that means we're going to go 4 times negative 18, that's a times c, to get negative 72 on top, and we'll place our positive 21 on the bottom. Fourth step, we have to solve our diamond problem so that when you multiply, you get the top, and when you add, you get the bottom. Basically, we're thinking multiply to get 72 and subtract to get 21, because the top's negative. That gives us 3 times 24, and since the bottom's positive, I would need the 3 to be negative. So if we check this now, negative 3 times positive 24 gives us negative 72. Negative 3 plus 24 equals positive 21. Fifth step is to go ahead and place these values with an x in the box. So we put negative 3x in one of the boxes and 24x in the other one. Sixth step, we're going to use the GCF, which stands for the greatest common factor of either the top row or the left column to get the first value for the outside. That means we need the greatest common factor of these two numbers, or we can do the greatest common factor of these two numbers. I'm going to go ahead and take the greatest common factor of 4x squared and 24x. So the greatest common factor number-wise is a 4, and they both have at least one x. So I'm going to take out a 4x. The last step is to solve for the remaining outside values to get your factors. So what this means is I look at that 4x, and I think 4x times what will give me 4x squared? It would be 4x times x. And then I can continue on. 4x times what will give me 24x? 4x times positive 6. And the last one can be x times what is negative 3x? Negative 3. And just to check it, notice that the negative 3 times the positive 6 does give us the negative 18 in the bottom right square. Now all we got to do is write these out as our factors of 4x minus 3 times x plus 6. Let's take a look at our next one. 6x squared minus 39x plus 60. First step, set up the diamond box. Next step, we're going to place our 6x squared and our positive 60 in the generic rectangle, or the box. All right, we go 6 times 60 to get the top and put our negative 39 on the bottom. So we have a positive 360, so we're thinking multiply and add to get 39. So when in doubt, you can make a list. This will be fun, trust me. 1 times 360, nope. 2 times 180. I could talk about like strategies to come up with a list, but you can always just use the calculator. And here we go. Nope. Doesn't add up to it. Nope. Still not there. No. Did I mention at the start of this video how much fun factoring can be? We're still looking for something. Ah, finally. The only thing left on the list is 18 times 20, but 15 times 24 adds up to 39. So we can put that over in our diamond. Now, 15 times 24 is 360, but we need it to add up to negative 39, so both of these need to be negative. Most problems that you get do not require that much work to find the answer to the diamond problem, thankfully. All right, let's continue. We can put our negative 15x and our negative 24x in the box, And now we need to find the greatest common factor of the top row or the left column. So I'll just take the top row. 6 would be the number that goes into 6 and 24, and they each have an x. So I'm going to put 6x out there. Now I just fill in the rest by finding out what do I need to make the inside work. So 6x times x will give me 6x squared. 6x times negative 4 gives me negative 24x. And x times negative 15 gives me negative 15x. And just to double check, the negative 15 times the negative 4 does in fact give me the positive 60. So that's it. Our factors are 6x minus 15 and x minus 4. But hold on. That's not the best answer. We did some factoring. But take a look at the first thing, 6x minus 15. Can you factor something out? Yes. You can factor a 3 out of the 6x minus 15. So if you were asked to factor completely, that would be your answer, because you got to factor out the 3. There is another approach I could have done when I looked for my greatest common factor. Let's take a look at what another option here was. Let's take a look at what would happen if I took the greatest common factor of the left-hand column instead of the top row. So if I look at the 6x squared and the minus 15x, the biggest number that comes out of that is a 3, and they both have an x. Now I can use the 3x to find the rest. So 3x times 2x gives me 6x squared. 3x times negative 5 gives me the negative 15. And then the 2x times negative 12 would give me the negative 24x. And negative 5 times negative 12 still gives me positive 60. So let's write those. So if you compare that to our first answer, it looks a little different. But what you would need to do on this one is divide 3 out of the second factor, and this would take you to the same answer we got before. But my guess is you're still shaking your head over that super long list we had to make to fill out our diamond problem. And guess what? There's a way to avoid all that work. If I could tell you we didn't have to make such a long list, would that be something you'd want to know? Let's take a look. So how do you avoid the crazy diamond problem? Sometimes you can avoid it by looking at your A, B, and C value in the original problem and seeing if you have a common factor that you can take out. So when I look at the 6, the 39, and the 60, I can actually divide all of those numbers by 3. So then I rewrite it as 3 times 2x squared minus 13x plus 20. That still would take us back to our original problem. We're just taking out the 3 at the start instead of at the end. And now I can make my diamond box, place my 2x squared and positive 20 in the box, and now I have 2 times 20 for the top and negative 13 on the bottom. So I'm thinking multiply to get 40 and add to get 13. Hey, that's part of my multiplication tables. That's just 8 times 5. I don't even need my list. So 8 times 5 equals 40, and it adds up to 13. But since it's a negative 13, we need negative 8 and negative 5. Those go into the box. And now I can find the greatest common factor of either the top row or the left column. I'll take a look at the top row. I know I can take out a 2 and an x. And that leaves me with an x on top. And then I have 2x times negative 4 to get negative 8x, and x times negative 5. And just to double check, negative 5 times negative 4 gives me the positive 20 in the bottom right-hand corner. So now my factors are 2x minus 5 and x minus 4. So, way easier than that gigantic list we have. But watch out, the one thing you can't forget is right now, those aren't my factors. I'm missing one of my factors. So if you're going to factor something out at the very start, don't forget it needs to be part of your answer at the end. And now you can see I have the same answer both ways. Another thing I wanted to point out with the first way we solved it is the reason why we don't find the greatest common factor of both the top row and the left column. Because if we did that, we would actually end up with 6x instead of the 2x, and then when you multiply that, you don't get 6x squared, you get 18x squared. So the greatest common factor, it's best to just stick with using it once and then using your logic to get the rest of the outside. You will run into problems when there's a common factor that can be taken out. Notice in the second one, my 2x and x, they are the greatest common factor of the top row and the left column. So finding the greatest common factor of everything will work when there's no common factor that can be taken out of the original problem. Hopefully you've learned from this problem the value of factoring out a greatest common factor at the very beginning. Alright, it's your turn to go ahead and pause the video, try doing this one on your own. Notice that there is a negative a value on this one, which presents a little bit of a challenge, which we'll talk about when we look at the solution. But go ahead and give it a try, and then check your answer. So set up your diamond box, place your negative 5x squared and positive 12 in your box part. Negative 5 times positive 12 gives us negative 60 on top and negative 4 on the bottom. You can always make a list if you get stuck, but hopefully you thought about 6 times 10, and 10 minus 6 is 4. So we get 6 and 10, and we need it to add up to a negative 4, so we would need the 10 to be negative. Those go over to your box, and then I'll go ahead and just find the greatest common factor of the top row. In this case, I have a 5 and a 10, so it would be a 5 and an x. And I'll go ahead and make this negative 5x. That leaves me with negative 5x times x to get negative 5x squared, negative 5x times positive 2 to get negative 10x, and x times positive 6 to get 6x. Notice that my positive 6 times positive 2 does give me the positive 12, and I can go ahead and write my factors. So when you have a negative a value, it actually leads to two options on how you represent your answer. Because I can make negative 5x squared by using a positive 5x and a negative x. So let's take a look at what would happen if I made that choice, and I'll leave our first answer out so we can compare. So this time I start with a positive 5x. That means that the next thing I could write down would be a negative x, because 5x times negative x gives me negative 5x squared. I could have 5x times negative 2 to get my negative 10x, and then the last thing I would do is negative x times negative 6 to get my positive 6x. This time we get a negative 6 times a negative 2, which still gives us a positive 12. But now we have an alternate solution that looks like this. Both of these solutions work. In addition, if you want to take the factor of negative 1 out of that second factor, negative x minus 2, you could even write this if you wanted to. So all three of these are acceptable answers for factoring this problem. Last problem. Go ahead, pause the video, give it a try. The diamond problem on this one isn't the easiest one in the world. You might end up making a long list. Hopefully you'll come up with the diamond problem answer without having to make a list. First step, make your diamond box, fill out the box, and 6 times 35 gives us 210, and on the bottom we got 31. Now you might have made a list, and man, it could have turned into a really long list. But 210, an easy way to multiply something and get a 0 on the end is to just multiply by 10. 21 times 10, it equals 210, and it adds up to 31. It can go over in our box. And then I'll go ahead and find the greatest common factor of the top row, which would be 2x. And actually, the greatest common factor of the left column is 3x. But once you get 1, I suggest you just figure out what needs to go there to make the inside true. So 2x times 3x is 6x squared. 2x times positive 5 would give me the 10x. and 3x times positive 7 gives me the 21x. And just to check my work, positive 7 times positive 5 does give me the positive 35. So my factors are 2x plus 7 and 3x plus 5. And that'll conclude our video on how to factor quadratics.